Section 10.3 is on page 477, talks about the Fourier convergence theorem, and this is what it says. Suppose that f and f prime are piecewise continuous on this interval from negative L to L. Further, suppose that f is defined outside this interval so that it is periodic with a period of 2L, then f has the Fourier series, the traditional. Nothing changes. Same thing as what we did before. Whose coefficients a sub 0, a sub m, and b sub n are given by equation 2 and 3 from the previous section. The Fourier convergence of f of x at all points where f is continuous, and it converges on this interval from f plus f minus divided by 2, which is the average, at all points where f is discontinuous. Note that, and they tell you what this is. This is the average. Mean means the average value of the right and the left hand limit at the point x at any point where f is continuous. Basically, you set the positive equal the negative equal f of x. We start off with the first problem, page 481, problem number 2. It says, find the Fourier series for the extended function, sketch the graph of the function to which series converge for 3 periods. So if I look at this, from negative pi, let's say this is negative pi, to 0, that is just 0. And from 0, let's say that's pi. This here would be y equal x, so it would look something like this. One end excluded, the other end included. And if I sketch another period, well, it's going to do the same thing. If I move to 2 pi, and a third period, assume this is 3 pi, so pi, 2 pi, 3 pi, and it's going to extend all the way to 4 pi. And that would be 3 full periods. Now, the solution to this, the traditional, in this case, we're getting more specific. F of x is a sub 0 over 2 plus the series n equal 1 to infinity. You could use m, of course, of a sub n, the cosine of n pi over lx, plus b sub n, the sine of n pi over lx. Well, in this case, if I really get L out of the way, the period for this is from negative pi to pi, that's 2 pi, which means L is half of that, since I'm going to run from negative L to positive L. So always remember that the period is actually twice L. So if I start by finding a sub 0, and we know how that works, let's get a sub 0 out of the way. A sub 0 is going to be the integral from negative 1 over L, 1 over pi, the integral from, it's going to be from negative pi to pi, but we know from negative pi, you know what, let me write it out. From negative pi to 0, it's going to be 0 times 0 dx, plus the integral from 0 to pi of x dx, and that turns out to be 1 over pi times x squared over 2 evaluated from 0 to pi, that doesn't look like a 2, and that turns out to be 1 over pi times 2 into pi squared minus 0, so that turns out to be altogether 1 pi over 2. So here I got what a sub 0 is. I know it's going to be pi over 4 when I'm done with this. If I find a sub n, That is 1 over L, the integral from negative pi to 0, 0 times, and that's going to be 0, of course. No need to write that down, but I'm going to write that down for your notes. N pi divided by pi x. So those cancel out. That makes life a lot easier. And the integral from 0 to pi, in this case, it's going to be x times the cosine of nx dx. And that would be 1 over pi times, so this is 0, and here I didn't mention that was 0. That would simply be, if I use u equal x, 1 and 0, dv is cosine of nx. That means it's going to be the sine of nx divided by n, and this is going to be negative the cosine of nx divided by n squared. So positive and a negative. That's going to be x sine of n x all over n, don't mix the angle with the value, plus cosine of nx divided by n squared, right? And I'm going to evaluate that from 0 to pi. That's going to equal 1 over pi times, if I throw the pi in, cosine of n pi is, sine of n pi is 0. Cosine of n pi is 1, 2, you know what, let me write it down. Minus, if I put a 0 in there, that's going to be 0 plus 1 over n squared. So this is going to be 1 over pi times negative 1 to the n over n, let me make sure n equal, yeah, minus 1 over n squared. So altogether, if I really look at this, that should be a squared, my mistake. So if I really look at this, and let's see how this works. If I let n equal 1, I'm going to get, so I'm only talking about this, the 1 over pi I'm going to leave out of this. N equal 1, I'm going to get negative 1 over 1 squared minus 1 over 1 squared. I'm going to get negative 2 over 1 squared. If I let n equal 2, I'm going to get 1 over 2 squared. If I let n equal 2, I'm going to get, oh, it's going to always be negative 1. Let me check. Okay, I see the mistake. There we go, much better. If I let n equal 2, I'm going to get a positive 1 over 2 squared minus 1 over 2 squared. That's going to be a 0. N equal 3, I'm going to get negative 1 over 3 squared minus 1 over 3 squared. I'm going to get negative 2 over 3 squared. N equal 4, can you guess what I'm going to get? 1 over 4 squared minus 1 over 4 squared. That's going to be 0. So it seems the evens are done, and the odds are going to remain. If I let n equal 5, negative 1 over 5 squared minus 1 over 5 squared. That is negative 2 over 5 squared. So altogether, it appears I'm getting 1 over pi times a negative 2 over 2n minus 1 squared. That should be the odds at n equal 1. So this is my a sub n. You know what, let me just circle that. Sometimes when you print it, the highlight come out to be a bit hard to see. And now if I look at b sub n, well, that's going to be 1 over pi, and I'm going to jump straight to it. The integral from negative pi to 0, from negative pi to 0 is going to be 0. It's going to be from 0 to pi of x times the sine of n pi n x dx. That's going to be 1 over pi times, and if I come up here and make dv as sine of nx, this is going to be negative the cosine of nx over n, and negative the sine of nx over n. And now if I multiply x times, that's going to be negative x the cosine of nx over n. And if I multiply those by a negative, it's going to give me a positive sine of nx over n squared, evaluated from 0 to pi, 1 over pi. Throw the pi in, negative pi times cosine of nx, n pi is negative 1 to the n over n, plus sine of n pi is 0, minus, if I put a 0 in there, I'll just get a 0 minus 0. So okay, that's really simple. In this case, that simply turns out to be, the pi's cancel out, a negative 1 to the n plus 1 over n. That's pretty much it. So if I get to write, and let's label that, if I find f of x, which is a sub 0 over 2, a sub 0, I got it to be, and it's right there, pi over 2 divided by 2, plus the series n equal 1 to infinity of a sub n. Just mark it a bit so you can see it. That is really 1 over pi times negative 2 over 2n minus 1 squared times the cosine of 2n minus 1 x plus a negative 1 to the n plus 1 over n times the sine of nx. And that would be my final answer. Now, something to look for. Assume that, number 7 through 12, assume that the given function is periodic, extended outside of the original interval. Find the Fourier series. Well, x minus x cubed. And let me see if I can remember this. From calculus, if I integrate from negative a to positive a f of x dx, do you remember that that would be a 0 if n is an odd function? And it'll be twice the integral from 0 to a if n is an even function. Right? So that could save me a lot of time. I'm going to start with by finding, well, let's see, f of x is a sub 0 over 2 plus the series n equal or m equal, it makes no difference, of a sub n, the cosine of n pi over lx plus b sub n, the sine of n pi over lx. And let me get a few things out of the way here. If I look at L, the length is really 2, the period is 2 units, which equals to L, which indicates that L equal 1. So if I put L equal 1, that's going to put a 1 there and a 1 there, and that's going to be n of pi. That's going to make things a bit simpler. Now, if I want to find a sub 0, watch what happens. That's the 1 over 1, the integral from negative 1 to 1 of x minus x cubed dx. I know that's 0. And if you're not sure, well, let's see. That is x squared over 2 minus x to the 4 over 4, evaluated from negative 1 to 1. That is 1/2 minus 1/4 minus 1/2 minus 1/4. Anytime you subtract a quantity from itself, you get a 0. Right? And if I look at a sub n, 1 over 1, the integral from negative 1 to 1 of x minus x cubed, the cosine of x dx. Cosine of nx dx. Now, I could say, let u give me x minus x cubed, 1 minus 3x squared, negative 6x, and a negative 6 and a 0. So, a lot of work. dv is the cosine of nx. You know what? Let me put that right here. Maybe that's how I should start doing this. Cosine of nx. This will be the sine of nx over n, negative the cosine of nx over n squared, negative the sine of nx over n cubed, and the cosine of nx over n to the fourth. I need 1, 2, 3, and 4. And wouldn't that be, oh boy, I'm going to write it here. Wouldn't that be x minus x cubed? It's a positive, then a negative, then a positive, then a negative. So it's going to be positive sine of nx over n plus 1 minus 3x squared times the cosine of nx over n squared plus 6x, the sine of nx over n cubed, negative times a negative, plus 6, the cosine of nx over n to the fourth, evaluated from negative 1 to 1. And let's see how this works. If I put a 1 in there, 1 minus 1, well, isn't that automatically a 0? So this first piece, when I put 1 right there, I'm going to get a 0, so that's gone. You know what? Let me put it down for your notes. 1 minus 1 cubed, which is 1. The sine of n times 1 over n, plus, if I put a 1 in there, isn't that a negative 2? The cosine of n divided by n squared, plus 6 times the sine of n divided by n cubed, plus 6 times the cosine of n divided by n to the fourth. When I put n a negative 1, wouldn't that be a negative 1 plus 1? The sine of negative 1, negative n divided by n, plus, if I put a negative 1 in there, that's a negative 2, the cosine of negative 1 n divided by n squared, plus minus 6, the sine of n divided by n cubed, plus 6, the cosine of negative n divided by n to the fourth. Now, this is a 0, and this is a 0, but observe. This is a negative 2 minus a negative 2. That's going to be plus 2. Those are going to undo each other. 6 of those. Let me just think really quick. Okay, let me go with those. This and that are going to cancel out. Cosine is an even function. It's going to absorb the negative. When you multiply by a negative, that's 6 over those minus 6 over those. Let me see what happened here. If I put a 1 in there, that's going to be 6 times n divided by 2. Let me double check. There it is. I caught it. I left the pi out. N pi x dx. So there should have been, oh boy, okay. There should have been a pi x on each of those. Yeah, much better. Okay, all of these should have a pi. and that's gonna make life much easier. Okay, so those two match just like before, nothing changed, except sine of n pi is a 0, and that's a 0, so I end up with a 0. Now, I could have saved myself all of this work. I could have said x minus x cubed, the cosine of n pi x is odd. Therefore, the integral from negative a to positive, from negative L to positive L of x minus x cubed, the cosine of n pi x equals 0. I could have saved myself all of that work. Well, for now, b sub n, that's not going to happen. That's 1 over 1, the integral from negative 1 to 1 of x minus x cubed, the sine of n pi x dx. That turns out to be a negative x minus x cubed, the cosine of n pi x over n pi, plus a 1 minus 3x squared times the sine of n pi x over n pi squared minus 6x, the cosine, that negative kind of disappeared, cosine of n pi x over n pi cubed plus 6 times the sine of n pi x over n pi to the fourth, evaluated from negative 1 to 1, and that turns out to be, if I put the 1 in, that's a 0. If I put the 1 in, minus twice the sine of n pi over n pi squared, that's a 0, minus 6 the cosine of n pi, that's a negative 1 to the n, over n pi cubed, right? Or maybe 2 steps will do, don't want to throw you off, minus 6 the cosine of n pi over n pi cubed, plus, when you put the 1 in there, that's a 0, minus, when you put the negative 1 in there, that's a 0, when you put the negative 1 in there, that's a 0, when you put the negative 1 in there, that is a plus 6 times the cosine of n pi. Negative or positive cosine is an even function, it absorbs that, plus 0. So I end up with minus 6 of those, minus 6 of those. That will be a negative 12, and cosine of n pi is negative 1 to the n pi squared. Don't mind that, that's my cat, sorry about that. And that means f of x equal 0 over 2 plus the series n equal 1 to infinity, a sub n is 0, plus b sub n. b sub n is a negative 12 times negative 1 to the n over n pi squared times the sine of n pi x. So simply f of x will be the series n equal 1 to infinity of, I could take a negative 12 over pi squared cubed times negative 1 to the n over n cubed, the sine of n pi x. And that would be my final answer. And there's my homework. Fix number 1. Number 1 should be negative pi less than or equal to x less than 0.